Sure. Sure, there'll be some people coming in, but we'll get started anyway. This is the player panel. We're going to take an in-depth look at JW, Kaltura, and Video.js. This is sort of the format is basically we'll give a 10-minute presentation of each of the talks and then or each of the players, and then we'll sort of open it up for questions across the various projects. And so we'll start with the Kaltura player. You can't hear me very well? There's no microphone, but I'll speak up a little bit more. Basically, we'll have 10 minutes of each project, and then open that up for questions. And we'll start first with the Kaltura player. So this is the Kaltura player. I'm Michael Dale. This is Itai. We work with Kaltura. We can go to the next slide. Kaltura player toolkit. We're going to give a quick overview of the architecture, talk about cross-player experiences, and then sort of the open source community and sort of documentation of the project itself. As we all know, HTML5 won out against Flash a while back, and now we've sort of have new set of problems and new challenges, sort of targeting a lot of different devices, supporting this sort of fragmented mobile ecosystem of devices. While desktop HTML5 has largely replaced the capabilities that were available in Flash, we still see a lot of gaps in the context of mobile offerings. So here you see some of the limitations outlined against mobile versus sort of a full-featured HTML5. This best case HTML5 on the right-hand side maybe would be like a Chrome or Firefox or a latest HTML5 browser versus sort of what you get by default on a mobile Safari or a mobile Chrome, depending on the Android version, of course. You can see it gets better over time for Android as new features get introduced. I won't go through the whole list, but things like autoplay is sort of a basic one. Chromecast full screen controls, being able to control the player interface. DRM. And basically the approach we've taken to deliver the experience across mobile is, of course, go into a native environment, launch an app, essentially. And we try to have the same player framework work against both native applications as well as sort of HTML5 based applications. And so the basic architecture is such that we can swap out a native player for a video tag player. Or in the case of the browser, this would be your Flash or your Silverlight plugins in cases where you need to deliver a feature to older browsers that don't have all the HTML5 capabilities to deliver a particular targeted feature. And then you can see here it broadens the amount of features that you can support as you include these native packages that can sort of do native callouts to native plugins for whether it's DRM or adding a little Chromecast screen or a native share or whatever it may be. Yeah, you want to jump? We'll do that one. Yeah. And then here's another basic. So going back to the player framework itself, it's all sort of JSON-driven, CSS, HTML templates, what you would sort of expect for a modern web HTML-driven player. It also has some extra features around sort of HLS normalization, which just means sort of a software HLS player in the case of desktop Flash, and software HLS player for Android as well. And then we'll go into a little bit of sort of how this JSON structure looks, just quickly because we only have 10 minutes or so, but just to give people an idea of how those components come together within the player system. Well, pass it over to Ty.
Hi, thank you, Michael. So basically, as Michael mentioned, we have we actually wrap each player as an abstract layer, and on top of that, we build like JavaScript plugins, HTML template, and CSS in order to configure how the UI will look like. We have a nice studio that you can check in and out the plugins, and then you will see them on the screen. This is part of the or the player package. It's all turned out into a JSON file that actually tell us which part of the plugins we should turn on for this specific player. Each plugin also have its own JavaScript for the logic, templates for HTML if it's a visible plugin, and the CSS of course for the look and feel. Of course, our player needs to handle multi-screen experience. So how do we tackle it? So first of all, the player must be responsive. It means every UI component have its own priority, if it's high, medium, or low. And by that, we reduced the number of components for a smaller screen, and of course, put them all on the big one, like TV or iPad versus iPhone. One more feature that we have on the player is, of course, the related video. It allows you to see the experience when you finish the video to go to the next one. And we have some nice APIs. You can do it from the Kaltura platform or from your platform, to add the your type of related video. Adaptive streaming. So as Michael mentioned, we must support adaptive streaming, HLS, of course, due to the iOS compliance. So we took the HLS and developed it also for Flash and for Android, that we can serve better all the devices, and build some more feature on top of the HLS. For example, ad stitching. And of course, MPEG Dash, it's now going to take a big part of our life, including the DRM, such as Chrome lately disabled the Silverlight, so you must do today DRM using the media extension, encrypted media extension. So this is also a field we are getting into.
Or just jump into the demo if you want. Just go ahead and, you want to shut up the demo real quick? I'll explain.
Sure.
Okay, so now what we're going to quickly show is the player doing that native call out. As many people are probably familiar, if you play a video from Safari on a iPhone, you often you'll get the sort of Apple UI for the player. And what we'll quickly show here is this is sort of a Safari, or sorry, that was the Safari browser. Now we jumped into the Kaltura player in a native application. So you're able to get your own custom controls. Notice this is not the same controls that Apple provides, and notice you have sort of custom image overlays. That's something that normally is not doable in an iPhone environment, and this sort of enables you to sort of seamlessly call out and get all your customizations, all your business logic, all your player functionality in the native environment. And I think with that we should switch to the next. There's a lot more slides, but I don't know if we got to everything. It's all open source community. That's important. We're at an open source conference. Check out the project on GitHub. There's a lot more information there about getting started with it and fun stuff, all that fun stuff. Thank you.
Thank you.
Keep an eye on the time.
Come on, you can do it. Yeah, there we go. Where's the mic? Is this?
You just have to hold that. It's not a mic. It's just for the recording.
There it is. Okay, hi. My name is Steve Heffernan. I'm going to talk quickly about Video.js. It's an open web player. It's the one with the seagulls and the dolphins, and I swear we have the rights to use that video. Major features are the HTML5 video tag everywhere. One of the original goals for the project was to make that tag possible in older browsers like IE6, IE7, and IE8, or to use MP4s in Firefox. Less of an issue these days, but it was one of the original goals of the project. We provide a common JavaScript API between HTML5, Flash, and other players like YouTube, Vimeo, SoundCloud. So if you're looking to kind of build on top of those players and you want a consistent API across those, that's what we provide. And the API looks very similar to the video element API. So if you're familiar with that API, you're familiar with the Video.js API. You can style the player using CSS. So if you change the background color of the progress bar in one place, it will work whether HTML5 is being used or Flash or one of the other players. You style it once using a technology that you're used to, CSS, and it works everywhere. We have a pretty large community of developer plugins, so people building on top of the project. So we try to keep the core project very small. We don't add many more features than what the video element supports itself, but then across all the different players. And then all of the additional features that you might want to add in, you'll find in our community of plugins. And then finally, it's Apache 2 license, so free to use in whatever use case you want. Quick little history on the project. Started building it back in 2010. Was going through the Y Combinator Startup Accelerator program. If you've heard of that, it's we were building a startup called Zencoder, which is transcoding API. During that, we went out to Mountain View, California, and rented this house in the middle of the woods to just kind of hack away in. And we stayed there for 4 months, miles away from anybody else. And on the weekends, my co-founders would go home to their families, but I didn't have family, so I stayed in the house all by myself on the weekend. And out of pure boredom, I started just building controls on top of the HTML5 video element. And so that's essentially how Video.js was born. Fast forward to a couple years later, a company called Brightcove. It's a larger online video platform that powers a lot of the major video websites out there. Acquired Zencoder, our startup, and at the same time put me full-time on Video.js and kind of became the primary corporate sponsor of the Video.js project. So I'm not working on full-time, and it's a great gig. And that brings us to today. This is the current website. So who is using Video.js? So actually Twitter, Dropbox, GitHub, Instagram, Tumblr, a lot of big brands. A lot of this just in the last year. So it's been a very exciting year for the project. And yeah, it's been really exciting to see these other groups come on and even start to contribute back to the project. A lot of times you have big companies like this just use it, but they're actually like helping out, contributing back. So that's great. And then because of the acquisition that Brightcove acquired the Zencoder, they're actually now implementing Video.js as their next generation player. So all of the websites that use Brightcove will also be using Video.js in the near future. So lots of progress in that area. Some stats here, a couple billion views a month. That's not including the Twitters and Dropbox. They use their own downloaded version. The most interesting one to me is the core contributors. So we've had up to over 100 core contributors now, which is really awesome. This last year we put a ton of work into our processes around pull requests and issue management and all the stuff on GitHub that can be really difficult to wield as you're trying to build the project and also manage the community. And we've been working on that really hard, and it's paid off. Some of the most recent versions were almost entirely brand new contributors, people who had never touched the project before. So pretty proud of the progress we made in that area. This is what the community looks like. We've got a core team, about 6 guys from different roles. And then, as I said, over 100 different contributors from small patches to larger contributions all along the range. And then finally, version 5.0, we're got some major changes coming. No major API breaking changes if you're building plugins on top of it, but we've got a new default skin that we're really excited about. We worked a lot on cleaning it up. Extensibility, so making it easier to add buttons to the control bar, and responsive design. So like people adding the player into responsive sites, that's been a big request. adaptive streaming support, so both Dash and HLS, and we've been building this in a way, well, we're still working on it, but we're attempting to build this in a way that we can share as much code as possible between Dash and HLS, and including across media source extensions and Flash. So doing as much of the work as we can in JavaScript and then just passing the bytes to where they need to go at the end. So that's been a really fun project, and if you're interested in that type of streaming technology and would be interested in getting involved, please let me know. Improved accessibility. There's been a lot of talk around accessibility in video players lately, and we've certainly heard that and been stepping up our game in that area. For one, we've integrated with Mozilla's VTT.js project, which is a very awesome implementation of VTT captions in the browser. It's the same library that's used inside of Firefox to display the captions, and so we're using that in the player as well. And then just a minor fix, we fixed the tab order. It used to be that you would tab through the controls in VideoJS and they would go in any random order, and we've fixed that. It's now cleaned up. And then finally, easier extension. Last year, as I said, we were focused on kind of the core code base and like how you can contribute back to it. And this next year, we're really going to be focused on how you build on top of it with things like a Yeoman plugin generator and easier way to build, design and share skins for the player. So yeah, it's going to be our focus for the next year. And that's it. So yeah, as I said, we are open to any new contributors. As you guys, if you're interested in helping out with the project, we'd love to hear from you. Just come and find me after this. Thank you very much.
Come on in. Leave some room over there in case some other stragglers come in. Gotta hold it. One last chance.
All right.
Good enough. All right. Okay, so my name is Pablo Shklevsky. I'm here with JW Player, and happy to be here. So just get started. Oops, actually just, oh, did I lose a slide? I moved a slide. That's the slide I wanted to show. All right. So a little bit about JW Player. JW Player is one of the oldest open source video players on the web. It was written first in 2005. So basically predated widespread video adoption on the web. It was the first player that launched with YouTube when they first launched up. So right today, as of last month, we streamed 17 billion video streams across 1 billion unique viewers across 3 million websites. So really pretty broad scope. So I'm going to talk today a little bit about the internal architecture of the player, not so much the features, but sort of how it's constructed, kind of at a high level. Happy to talk about it later if you want more detail. So essentially the way it works is when a user comes in, a developer will configure a player using similar JSON to Kaltura's player called jwplayer.setup. What the player will do is it'll determine the correct setup mode for that user's content based on browser capabilities, based on the content. So it'll either set up in a Flash player or in an HTML5 player. HTML5 is the default. At that point, the user will have access to a JavaScript API, which will then translate down into the lower level player. So there's one API that the user will need to interact with, and from a developer's perspective, you don't have to actually care whether or not a user is viewing your content in Flash or in HTML5. It all behaves the same way from the API. What happens is that lower level events will bubble up from the media through to the lower middle tier API through to the public API. We have a plugin structure, plugin architecture. Actually, there are two different types of plugins for legacy reasons. We've got Flash plugins, which are loaded by the Flash component, and that allows users to put UI in Flash, for example, in full screen mode, where HTML elements are no longer visible. JavaScript plugin, which sits on top of the standard plugin API. So the only difference between doing a plugin API or doing a JavaScript API and writing JavaScript is that the API is embedded in your code, and the plugins can be loaded off of CDN at runtime. So internally, in both Flash and HTML5 modes, what we have is a concept of a media provider. So instead of model view controller, the model is essentially controlled by the media. So for example, in HTML5, the model is the video tag, and all events coming up from the video tag drive the UI. So in Flash, you have multiple media provider types, for example, progressive download versus RTMP versus YouTube. So it sort of standardizes a model for consuming media and displaying the events. And the provider API, or the provider interface rather, is fairly simple. It's play, pause, seek, stop, load. So essentially everything that different all media requires those basic tenets. So that's what the provider API exposes. Some examples of media providers: RTMP, for those of you who are familiar with Flash Video. It's a sort of a legacy streaming format, still fairly popular with the CDNs, although we're seeing much less adoption as users move into HLS. So we have an HLS implementation for adaptive streaming. In Flash, loads MPEG-2 TS, does the transmuxing into FLV, and then pushes it to the Flash renderer, which works okay for now, and we actually see quite a number of folks still on HLS, even as Dash is becoming more and more popular. We've got a little sneak peek here of Dash.js running in JW Player using the HTML5 provider model. So we actually have wrapped Dash.js here into a very simple media provider API, and that MPD is loading here. So the demo gods have smiled upon me, so I'm going to come back here before it breaks. It's not going to break, right, Steve? Steve's contributor to Dash.js, so we're actually wrapping his work. Which is great. So a little bit of a sneak peek on our next iteration of our architecture. Flash and HTML5 running side by side works great, but it's pretty clunky, and you have to implement features more than once, which as a developer you never like to see. So we've made some progress with the browsers. Some of the blockers for migrating entirely to HTML5 for the display, such as full screen support in native browser full screen, plus MP4 delivery across many more browsers, Firefox included. That's really enabled us to abandon the Flash rendering mode as a full player experience, and we're able to just use the Flash providers as dumb chromeless media playback components. So we're essentially going to be reusing the HTML5 provider model. We'll wrap it with a Flash loader, which will load the media only in that Flash display. That'll swap out the video tag, and we'll render video that way. And that allows us to write application logic once in JavaScript, and Flash can hopefully die a slow and painful death, and we can eliminate it from the player. Right. Ads is the answer. So we have some cool new features. This is the one feature demo that I'll show, which is Chromecast. So that's a cool new device. One that we have really adopted quickly, and are thankful for Google for implementing it the way they did, which is that they provide a browser, a full HTML5 browser experience, and a very lightweight communication layer between the two. So I'm going to show a little demo of how this works with the JW player. And it's not a live demo because Chromecast sucks on public networks. But what you're seeing here is on this computer over here, we've got a JW player. We hit the cast icon, and it starts a Chromecast session on your TV. What's happening there is there's an HTML5 app that's a JW player in full screen mode with a little bit of custom skinning on top of it. And there's a communication between the sender app, which is the player. The player sort of becomes a sender, and the receiver, which runs on the TV. And so basically what's happening is that the Chromecast application is signaling to the desktop application the state of the player. The player just renders a UI. For example, here's an ad. The player knows that an ad is playing, so I'll show the companion ad. The user can actually click on this, which advertisers love, and the Chromecast application renders all the video playback and essentially takes over the playback session. So, for example, in this advertising use case, all the beaconing that's going on to the ad server is coming from the TV. So you can really just close out your web browser, and your video player will continue to play as configured. So, get out of there. So GW Player has been an open source video player since its inception, since back in 2005. We recently migrated from pretty cobweb infested Subversion repository over to a shiny new GitHub repository. We've seen a significant uptick in open source contributions, probably just due to the ease which Git allows you to submit pull requests and review them and have a conversation there. All in one place, so it's really nice. In addition to the player itself, JW Player, the company, which does much more than just a video player, contributes to multiple open source projects. We upstream when we can, and we've written a few projects of our own for our own internal purposes. So one of the nice things about our sort of our approach is that sort of since the beginning we've had a very active developer community and also an active support community. So our forums are still very active. We recently implemented a sort of a democratic roadmap just to see what the community wanted in terms of new features and functionality. Dash was at the very top of the list, followed by CSS skinning and DRM in HTML5, which essentially means Dash. So we know where we're going for the next couple of months, but can't wait to see how that turns out. So that's it. That's all I got.
All right.
So
Stand over here.
right now,
So-
so we've got about 15 minutes left.
So-
So yeah, do you want to?
So we'll basically do a Q&A. So you seen the presentation? Any questions?
Where's the benchmark? The three different solutions.
We have the
What bench? what? Oh, the best one. Yeah.
Yes.
I can say something about that. I mean, it's actually kind of a difficult problem because of the way. I mean, there's so many different use cases and features that you would potentially test against, and a lot of things come into play when actually measuring, the first time the ad starts to display, or the player starts to display content, because there's ad network fulfillment, and there's a lot of different factors that can come into sort of trying to make a objective, attempting to make an objective analysis. And also it's difficult for any given vendor to conduct that objective analysis to begin with. So I think it'd be a good project for somebody to take on if they were interested in doing that.
Next question?
What about user and developer conferences? I think it's funny when you have so many video web players, there's nobody who actually have an end user conference and programming conference.
So we actually. So the question was, how about end user conferences for these products? So JW Player had our first conference last May. It's called JW Insights. We're going to do it again this year. So feel free to come in New York City in May.
We have Cultural Connect that come in Cultural Connect. Yeah, like it's also we did hackathon Let's Connect with a very cool project. So you're welcome to follow and come to the next event.
Yeah, we haven't done one yet.
Yes. We don't. I'm sure this is something that all of us have struggled with Facebook. We've been in discussions with them. They're very slow to move on HTML5 players in the newsfeed. So we actually, for JW Player, we have a legacy player that works in Facebook, but it's not our core player.
Yeah, also us use a Flash player on Facebook, but Twitter lately opened the HTML5 and it's working there great. So
just use Twitter.
Yeah, same situation.
Yeah.
That's actually for you. Where did your bug tracker go?
The bug tracker. Well, so we currently
no more bugs.
there's no more bugs, right? So we're using GitHub for the pull requests, and we have our forums, which are the traditional.
It was a nice repository of known issues. I have a lot of bad links now.
Please let's connect afterwards, and we'll yeah.
Yes?
audio, multiple language natively.
Yes, so we support it in adaptive and HLS. So we have multiple audio tracks and a user interface to select between the two of them.
Yeah, we support it also on HLS, on smooth streaming, both on browser and Android native applications. Yeah, HLS.
VideoJS doesn't have that yet. We're working on that with the integration with Dash.js.
We'll give you another lonely weekend. You're gonna wrap it up.
That's right.
Other question?
Why the choice of a no commercial license, which is not appreciated by a lot of open source users?
Yeah, it's been a topic of internal discussion for quite some time. We may transition to a more popular license over time.
Open source maybe, because a lot of people say it is not open source.
We've definitely heard that. Yeah,
What's your licensing scheme at the moment?
it's Creative Commons Attribution, non-commercial, share alike. Yeah.
Yes, another question over there?
Well, I think it's worthwhile. I guess Kaltura has a GPL license, which is also like less than, say, an Apache license in terms of the freedoms that it allows, but you know, still allows commercial distribution in that case. But.
Other questions over there?
Just one of Dash.js today, and now it's starting for Dash, but can we expect in the future that the browsers will implement Dash internally?
So the question was, Dash, as it's sort of consolidating in terms of the standards, will we see native implementations in browsers for Dash? My guess is absolutely not. So this has been sort of a discussion with the browser vendors, whether they should implement streaming standards such as HLS, such as Dash. The media source extensions API is a reflection of their approach to streaming formats. They're sort of agnostic, I guess, is the official approach. Yes, I don't think so. Yeah.
Yeah, there was actually, Microsoft announced recently that they are building Dash into the browser just so you can use the MPD URL, but the other browsers won't. So it won't be something we can just rely on. We'll still need a program like Dash.js. But Dash.js is something that we're all kind of collaborating on right now, so that's at least, you know, a positive. You'll be able to turn to one library.
Yeah, I think it's worthwhile to emphasize the fact that we have one Dash.js library that everybody's sort of targeting against, and that's going to help the standard effort a lot, because if you have lots of different implementations, it's very difficult for, you know, a server software can say it's working with one streaming library and then it won't work with another, and especially across browsers, it becomes very complicated to support a standard. As you've seen with HLS, we sort of have standard by Apple definition, you know, like what if it works on the iPad, then it's legitimate HLS. If it doesn't, then it's something else, you know. and so something like that for Dash is really critical. In this case, it's, you know, if it works with Dash.js then it's Dash, you know, type thing. I mean, although not to say that, I mean, Dash obviously has a very verbose standardification process, and Dash.js doesn't include everything in that standard. So again, just a reference implementation is really valuable in sort of being able to actually deliver media to end users.
Other question? People in the back? Okay.
DRM? No questions about DRM? Usually very popular.
Why are you doing it?
Anything you guys want to add? All right. So check out the project.
Thank you very much.
Next up.